Event-driven architecture with serverless patterns. In modern cloud computing, event-driven architecture has become a fundamental approach for building scalable and responsive applications. This pattern allows different parts of your system to communicate and react to changes in real time, making your applications more flexible and efficient. Event-driven architecture is a design pattern where events trigger actions across distributed systems. Instead of components directly calling each other, they communicate through asynchronous messages. This creates loosely coupled components that can scale independently. Think of it like a notification system where different services listen for specific events and respond accordingly, without needing to know about each other directly. Every event-driven system has three core components. First, event producers generate and publish events when something happens in your application. Second, the event bus acts as a central router that receives events and delivers them to the right destinations. Third, event consumers process these events asynchronously, performing the necessary actions based on the event data they receive. In serverless architectures, events can come from multiple sources. A PI gateway triggers functions when HTTP requests arrive. Database changes from DynamoDB streams or Aurora can trigger processing functions. Object storage events from S3 Fire when files are uploaded or deleted. And scheduled events work like cron jobs, running functions at specific times or intervals. The event router pattern uses Amazon EventBridge to route events from sources to multiple consumers based on filtering rules. An event source publishes events to EventBridge, which then intelligently routes them to different Lambda functions based on the event content. This allows you to have multiple services react to the same event in different ways. Here is an example event structure. The source field identifies where the event came from, in this case order.service. The detail dash type specifies what happened, which is order placed. The detail object contains the actual event data, including the order ID and amount. This JSON structure is standard for EventBridge events. Queue-based processing uses Amazon SQS to decouple components with reliable, asynchronous message delivery. A producer sends messages to an SQS queue, which stores them until a Lambda consumer is ready to process them. This pattern is perfect when you need guaranteed delivery and can tolerate some processing delay. The queue acts as a buffer during traffic spikes. The publish-subscribe pattern uses Amazon SNS to fan out messages to multiple subscribers. A publisher sends a message to an SNS topic, which then delivers copies to all subscribers. Subscribers can be Lambda functions, SQS queues, email addresses, or other endpoints. This is ideal when multiple systems need to react to the same event simultaneously. Stream processing handles continuous flows of data using Amazon Kinesis. Data streams flow into Kinesis, which maintains the order of events and allows Lambda functions to process them in real time. This pattern is essential for scenarios like log processing, real-time analytics, or IoT data ingestion, where you need to handle high-volume, continuous data streams with automatic scaling. When building event-driven serverless applications, follow these best practices. Implement idempotency to handle duplicate events gracefully, ensuring the same event processed twice produces the same result. Add comprehensive observability with logging and tracing to understand event flows. Use dead letter queues for error handling to capture failed events for investigation. Finally, version and validate your event schemas to maintain compatibility as your system evolves.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.